ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನನ್ನ ಹೆಸರು ಚಂದನ್ ಎಂಜೆ, ವರ್ಕಿಂಗ್ ಆಸ್ ಲೆಕ್ಚರರ್, ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್, ಗೌರ್ಮೆಂಟ್ ಪಾಲಿಟೆಕ್ನಿಕ್, ಕಾರವಾರ. ವೆಲ್ಕಮ್ ಟು ಸೆಷನ್ 5 of Unit 4, Power Installations, of subject Electrical Estimation and Costing, 5th semester, with subject code 15EE54T. So topics covered in this session is: prepare the schedule of materials with specifications for the workshop. Use surface conduit system only. So in the last sessions we have covered how to draw the layout diagram, how to draw the single line diagram, and how to calculate the specification of materials, and what are the main materials required for power installations, and how to select a suitable material for our requirement. So these are the things we have discussed, and what are the standard procedures we have to follow while doing the power installations, and all the things we have discussed. Now by using all those knowledge, so we are going to solve the problem on power installation. So that is preparing the schedule of materials for the workshop. Here we are using only surface conduit system in a power installation. Let us take up a problem. So here this is the given example. In a workshop of 10 meter into 5 meter, following machines are to be erected. So first one, lathe machine, 3 phase, 440 volt, 2 HP. So next, grinding machine, single phase, 230 volt, 1 HP. So next, drilling machine, 3 phase, 440 volt, 1 HP. Prepare the list of materials with specification for the power circuit wiring for the above installation. Use surface conduit system. Here one workshop is given. What is the dimension of that workshop? 10 meter into 5 meter. So in that workshop, these 3 machines are going to be installed. We need to install these 3 machines, that is lathe of 2 HP 3 phase machine, and grinding machine of 1 HP single phase machine, and drilling machine of 1 HP 3 phase machine. These 3 machines have to be erected in a workshop of dimension 10 meter into 5 meter. So the solution, first we have to make some assumptions. So if you're doing any problem, before starting the problem you have to write the assumptions. What are the assumptions we are going to do here? So first assumption is height of workshop is 4 meter. We are assuming that the height of the workshop from the floor level is 4 meter. Okay, so that is the total height of the workshop. So next, the height of horizontal run from the ground is 3 meter. Means whatever the horizontal run we are taking, that is the surface conduit system we are taking, so in the horizontal through the wall, so that is from the height of 3 meter from the ground level. Okay, next, height of main board and switch boards from the ground is 1.5 meter. Means all the switch boards and all the starter boards and all main boards and all are placed 1.5 meter from the ground level on the wall. Okay, so that is one more assumption. So next is efficiency of motors is 80%. We are assuming all the motors having the efficiency of 80%, and power factor is 0.8. even though he is not given, but we are assuming that. So the motor efficiency is 80% and power factor is 0.8. And last assumption is cost of load and starters are not included in the cost estimation. Means while calculating the cost of power installation, we are not including the cost of starters as well as loads. Loads means machines. We are not including the machine cost. Okay, so like lathe machine cost and grinding machine cost, milling machine cost, we are not included in the cost estimation. So these are the assumptions we have to write before going to solve the problem. This is very, very important. So next, after these assumptions, we have to write the layout with wiring. So we know, we have discussed how to write the layout diagram and wiring diagram. So in the given problem, first we have to write what? So the given dimension workshop. What is the dimension he has given? 10 meter into 5 meter. So first I have to write the 10 meter into 5 meter workshop. Okay. Then after that, so I will write what? AC mains. AC mains to be placed near to the entrance. Entrance is to be marked, and near to the entrance AC mains we have marked. Okay. So next we have to see the problem. How many number of machines are given? There are 3 machines. Okay. First 2 HP lathe machine, that is 3 phase. Next 1 HP drilling machine, that is also 3 phase, and 1 HP grinding machine, that is single phase in nature. So now I have to place the machine, right? So this is the 1 HP grinding machine, our single phase grinding machine bed. Okay, and this is starter board of 1 HP single phase grinding machine. So that is to be kept 3 meter from the mains. Okay, so and the distance between your starter board to the grinding machine, as we know, the standard distance we are taking is 1.5 meter. Okay, so next in the another side of the wall, that is opposite to this wall, so we are placing what? 2 HP lathe machine of 3 phase and its starter board, and the distance from your starter board of lathe to the lathe bed or lathe machine terminal is 1.5 meter. Okay, and that is to be placed 3 meter from the entrance wall. And another machine, so that is 1 HP drilling machine of 3 phase, is placed 3 meter from the lathe machine. So that is sufficient space is provided for the operation of the each machines. Next, so this is the starter board of drilling machine, and the distance from your starter board of drilling machine to the drilling machine is again 1.5 meter, and we have provided with 2 earthing sets. This is one earthing point and this is one more earthing point. Okay, so this is how to write the layout. So and with the wiring diagram, this dotted line shows the wiring of the workshop. Okay, so here you have to remember, first if any given problem, first we have to write what? Assumptions. So next we have to write the layout with wiring diagram. So and this is the layout with wiring diagram for this given problem. So next we are going for the material calculations. So first what we have to calculate? First we have to calculate the main board equipments. What are the equipments which we are going to place in the main board? So that is, we are using energy meter. Along with the energy meter we are using main switch, and along with the main switch we are using MCB and ELCB and indicators. All these things are placed in the main board. Okay, first we have to calculate what are the equipments which we are placing in the AC mains or the main board of the workshop, and what are those ratings of that equipments or materials we have to calculate. First material we are using is main switch rating. So that is main switch we are using. So then, so we have to calculate the main switch rating, and you have to select the available main switch. So next, so for the calculation of main switch rating, what we required? The total current of the workshop. So that is total current is equal to current drawn by lathe machine plus current drawn by drilling machine plus current drawn by grinding machine. Okay, so here we have considered only power loads because we are calculating the main switch only for the power installation. Okay, so then total current or total load on the workshop is equal to the current drawn by lathe plus current drawn by drilling machine plus current drawn by grinding machine, because we have installed these 3 machines in our workshop. Then what is the approximate total current is equal to? So you know the formula, approximate to calculate the approximate load current for 3 phase machines. So that is HP into 1.6. So that is, what is the lathe machine horsepower? What is the lathe machine rating? So that is 2 HP into 1.6 plus, so what is the current HP rating of your drilling machine? So it is also 3 phase. So that is 1 HP, 3 phase machine it is. So 1 HP into 1.6 plus, so what is the current drawn by grinding machine? So this grinding machine is single phase machine. So this multiplication factor we cannot apply this multiplication factor for this single phase machine. So what is the formula for load current of a grinding machine, single phase grinding machine? So which is equal to HP into 735.5 divided by 230 into 0.8 into 0.8. Okay, so then, so what is the approximate load current is equal to 2 into 1.6 plus 1 into 1.6 plus 1 into 735.5 divided by 230 into 0.8 into 0.8. Okay, so then approximate load current is equal to, by solving this equation, you will get 9.8 ampere. So that is the total approximate load current of the workshop. So then while calculating the main switch, you have to take the factor of safety as 3. So then total current required by the main switch rating is, so 9.8 into 3, that is 29.4 ampere. Means our switch is capable of taking this 29.4 ampere, and hence, so these machines we are using 3-phase machines in our workshop. Along with the single phase, we are using ICTP, ironclad triple pole switch. Okay, so then what is the rating of ICTP? ICTP available in the market of, so here near to this value 29.4 ampere is 32 ampere. Therefore 32 ampere ICTP is required for our workshop in the AC mains panel board. Okay, so this is the one estimation or one material specification we have calculated. Next, what is the material required? We required MCB in the main board. Okay, we are calculating only the main board equipments. Okay, so next MCB. So you know the load current, we have calculated the load current in the previous step. So what is that? 9.8 ampere. So therefore the MCB of market availability is 15 ampere. 15 ampere rating is required. If you select 10 ampere, then it becomes underrated. Okay, so then next higher range is 15 ampere. So that is 15 ampere rating is required. Next, ELCB. So ELCB starting rating is 30 ampere. So we have selected 30 ampere with tripping current of 10 milliampere is required. How many ELCB is required? One ELCB of 30 ampere with tripping current of 10 milliampere is required. So next we required pilot lamps, that is indication for RYB. So we required how many pilot lamps? That is 3 neon lamps are required for the indication of RYB. So these are the 4 materials which we required in the main panel board. Okay, so after the calculation of this main panel board materials, next we going to calculate the individual starter materials. Okay, so what are the materials required for individual machines? In the individual starter board of each machines we are going to calculate. So next, first we take up the materials, list of materials and specification for grinding machine. Okay, first we will take up the grinding machine materials. So first what we have to calculate, the total wire length required from main board to switchboard of grinding machine. So we have to take the power from our main board to the switchboard of grinding machine. So then it has to taken through the wires, right? Then we have to calculate the length of wire required from your main board to the switchboard of grinding machine. Here the grinding machine is single phase. For the single phase, how many wires we required? 2 wires, right? So one is for phase and one more for neutral. So 2 wires, 2 into, so the length of wire required, which is equal to 2 into vertical distance plus horizontal distance plus extra for looseness and wastage we are taking. So what is the vertical distance from your main board to the switchboard? So that is vertical distance. We have assumed the horizontal run is 3 meter from the floor level, but we have placed the main board is 1.5 meter from the ground level. So that is to reach the 3 meter from 1.5 meter level, we required 1.5 meter. So that is vertical run. Vertically, how much vertically we are taking, vertical drop or vertical rise. So this is 1.5 meter vertical rise we are taking, and this is 1.5 meter vertical drop we are taking, because horizontal run is at the 3 meter level. So then again you have to come back to the switchboard of this grinding machine, right? So first I have to take the wire from the main board. So that is from 1.5 level 5 meter to the level of 3 meter. So then it has to go through horizontal run, and next I have to vertically drop it to bring back it to the 1.5 meter level, because my switchboard of the grinding machine I am placing at 1.5 meter level from the floor level. Okay, so that is 1.5 meter is vertical rise at the main board, and 1.5 meter is vertical drop at the end of switchboard of grinding machine. So next, plus horizontal distance. What is the distance from your main board to the switchboard of grinding machine? So that is in the first figure we have seen here. So that is how much from your main board to the starter or switchboard of your grinding machine? That is 3 meter. So that 3 meter we have taken here. Okay, plus extra we have taken 2 meter as extra. Okay, distance extra 2 meter for looseness and for wastage we have considered. So then what is the total wire length required, which is equal to 2 into 1.5 plus 1.5 plus 3 plus 2, so that it becomes 8 into 2, it becomes 16 meter. Okay, so then what is the load current of grinding machine? So which is this is a single phase machine. We have to calculate the load current of this single phase grinding machine, which is equal to 1 HP into 735.5 divided by 230 into 0.8 into 0.8. You will get 4.99 ampere. While selecting the size of the cable, we have to take the factor of safety as 2. Then the cable required to carry the load current is equal to 4.99 into 2, so that is equal to 9.99 ampere. Therefore, from the cable chart table, so we know that 1.5 square mm PVC insulated copper cable is required of length. How much? What is the total length of the cable? So that is 16 meter length is used to take the power from your main board to the switchboard of grinding machine. So now we have taken power from your main board to the switchboard of grinding machine. Next we have to calculate from grinding machine to the grinding machine terminal, grinding machine switchboard to the grinding machine terminal. Next, the total wire length required from your switchboard of grinding machine to grinding machine terminals box, which is equal to, we know that, so the grinding machine is placed 1.5 meter from the grinding machine switchboard, okay, or grinding machine starter board you can call. So then what is the total length of the cable required for the connection of your grinding machine from the grinding machine starter board or switchboard? So that is equal to 2, because here it is a single phase. We required only 2 wires, phase and neutral, into vertical distance plus horizontal distance plus extra. So then the total wire length required from your switchboard to grinding machine terminals is equal to 2 into, what is the vertical distance? What is the distance between your what is the distance between your switchboard to the floor level? So that is 1.5 meter. Means vertically we know that we are taking this wire through the channel which we have made in the floor level, right? So through flexible PVC conduit system, right? So then our switchboard is placed 1.5 meter from the ground level. So then we have to take it back to the ground from your 1.5 meter level. So that is vertical drop of how much? 1.5 meter. So then we are taking back to the rise of 1 meter at the bed level, right, in the bed of the machine. And next, so this is the horizontal distance. Horizontal distance we are taking 1.5 meter from the switchboard, right? So that is the 1.5 meter horizontal distance is taking, plus extra 2 meter for looseness and all we are considering. So that is what is the total length, 1.5 plus 1 plus 1.5 plus 2. So that is 4 plus 2, 6 into 2, so that is 12 meter. So then what is the size of the cable? Here the size is same. So 1.5 square mm PVC insulated copper cable of 12 meter length is used from your switchboard of grinding machine to the grinding machine terminals. Okay. So next material you have to calculate is total length of flexible conduit 30 mm dia required from your switchboard to grinding machine terminal, switchboard of grinding machine to the switchboard grinding machine terminal. So that is equal to vertical distance plus horizontal distance plus extra. Okay, here what is the vertical distance you required? 1.5 meter from your switchboard to the ground, and next that is vertical drop, and again vertical rise 1.5 meter at the machine side, plus horizontal run is 1.5 meter, plus extra we are considering 2. So that is equal to 7 meter. So flexible conduit is required of 30 mm dia. So next, what is the total length of PVC conduit, that is rigid PVC of 30 mm dia and 3 mm thickness required from your main board to the switchboard of grinding machine? or starter board of grinding machine, that is equal to vertical distance plus horizontal distance plus extra. What is the vertical distance you required? So one vertical rise you required at the side of main board, so that is 1.5 meter, and one vertical drop is required at the side of switchboard of grinding machine, so that is 1.5 meter drop we have taken. So next, what is horizontal run? Horizontal run is 3 meter, that is the distance from your main board to the switchboard, that is 3 meter plus 2 meter extra we are considering, so then total it becomes 8 meter. Okay, so then what is the saddles required? Number of saddles required is equal to this 8 plus this 7 we are taking. So both you add up both the PVC conduit, 8 plus 7 15 divided by 0.75, we are getting 20 numbers of saddles is required. Because why we are dividing it by 0.75? At every 0.75 meter we are placing one saddles. Okay, so that is total length of your PVC conductor is 15 meter divided by, at every 0.75 meter we are placing one saddle, so we are dividing it by 0.75, we require 20 number of saddles. So then, so we have taken the connection from your main board to the switchboard, and from your switchboard to the switchboard of grinding machine to the grinding machine terminals. Then what are the materials you required? So you required ICDP. Here the grinding machine is single phase, we are using ICDP. So what is the rating of that? We know the load current of that machine you have to calculate. So we have calculated it, right? See here, we have calculated it. How much? It is 4.99 ampere. We are taking it 4.99 ampere. So then while calculating the ICDP, you have to take the factor of safety as 3. Then total current is equal to 4.9 into 3, which is equal to 15 ampere. Therefore ICDP, that is ironclad double pole switch, because it is a single phase supply or single phase machine, we are using ICDP of 15 ampere rating is required. So then what are the other materials we are using? We are using capacitor bank, right? Power capacitor bank. What is the rating of power capacitor bank? Since the given HP of the motor is single phase 1 HP motor, right? So 1 HP single phase motor, so that is HP is equal to 1. Therefore 1 divided by 2.5. Why we are making 1 divided by 2.5? For every 2.5 HP we are using 1 kVAr capacitor, so that is, so it is less than 1, but we are taking 1 kVAr RKVA or 1 kVAr capacitor bank we are selecting. Therefore 1 RKVA single phase capacitor of 250 volt grade is used. Then what you required? You required starter. Since HP rating of grinding machine is 1, DOL starter are used. Okay, simple DOL starters are used. So this is the components which we required for the switchboard or starter board of your grinding machine. Okay, so and what is the cable and length, size, and what is the switch rating and capacitor rating and starter rating we have calculated. So next, in the same way we will go for calculation of starter board of next machine, that is lathe machine. Next, what are the list of materials and specifications for lathe machines required are? First we have calculate same way, same procedure we will follow while what we have followed for grinding machine calculation. First we calculate the total wire length, that is length of wire required from your main board to switchboard of lathe machine. Okay, so that is equal to we have seen the in the layout wiring diagram. So from the main board to the switchboard of lathe machine we have to calculate, so that is equal to here. So this is lathe machine is a 3-phase supply, we need to take into 3. So this three number of wires we required to take the power from your main board to the starter board of lathe. So that is 3 wires are required because it is a 3-phase machine. So that is 3 into vertical distance plus horizontal distance plus extra. So then total wire length required is equal to 3 into, so what is the vertical distance? So this 1.5, that is vertical rise from your main board to the ceiling level, or you can call for the horizontal run level. So this 1.5 is vertical drop from your horizontal run level to the starter board of your lathe. So 1.5 plus 1.5, what is the distance from your main board to the starter board of your lathe? See, you can see in this diagram here, this 5, from here to here the distance is 5. Okay, and from here to here the distance is 3, so that is 5 plus 3, so that is 8 meter. That is what we have taken here. See, 8 meter plus extra 2 meter we are considering. So that is, it becomes 13 into 3. So the total wire length required is 39 meter. So then we have to, this is the length of the wire, then we have to calculate the size of the wire, right? So then what is the approximate load current on that wire? So that is equal to load current of lathe machine plus load current of drilling machine, because on that side we are having two machines. For the two machines, current that cable has to carry, right? So that is load current of lathe machine plus load current of drilling machine. So what is the load current of lathe machine? Since the given machines are 3-phase, you know the simple way of calculating approximate load current. So that is HP into 1.6. that is, lathe machine rating is 2 into 2 HP into 1.6 plus load current of drilling machine is 1 HP into 1.6. that total current you will get 4.8 ampere. By taking the factor of safety as 2, then the cable required to carry the load current is equal to 4.8 into 2, so that becomes 9.6 ampere. So therefore, to carry the current of 9.6 ampere, looking at the table of cable chart, so we can see that 1.5 square mm cable is sufficient to carry the 9.6 ampere. Therefore, 1.5 square mm PVC insulated copper cable of, what is the total length you require? 39 meter. 39 meter length is used for the connection of your main board to the starter board of lathe machine. Okay. Next we'll see the total wire length required from starter board of lathe machine to the lathe machine terminals box. Okay, so that is from your starter board of your lathe machine to the lathe machine terminals. So here this is 3-phase, you have to take 3 into vertical distance plus horizontal distance plus extra. So therefore the total wire length required from starter board to the lathe machine terminal is equal to 3 into, so vertical distance is 1.5, so that is a vertical drop you are taking, and next 1 meter horizontal distance, vertical rise plus 1.5 meter of horizontal distance plus 2 meter for extra or looseness we are taking. So that is, it becomes 6 into 3, which is equal to 18 meter. So therefore 1.5 square mm PVC insulated copper cable of 18 meter is used from your starter board of lathe machine to the lathe machine terminals. Next we have to calculate total length of flexible conduit 30 mm dia required from starter board of lathe machine to the lathe machine terminals, which is equal to vertical distance plus horizontal distance plus extra. So that is 1.5 meter vertical drop, 1.5 meter vertical rise plus 1.5 meter horizontal distance plus 2 meter for extra. Total it becomes 7 meter, approximately 7 meter. So it becomes how much? 6.5, but we are nearing it to the next value, so that is 7 meter. Okay, so next, so this is a flexible cable from your starter board of lathe machine to the lathe machine terminals. Next, what is the total length of PVC conduit? Rigid PVC 30 mm dia, 3 mm thickness required from your main board to the starter board of lathe machine, that is equal to vertical distance plus horizontal distance plus extra. So that is equal to vertical distance is, this is vertical rise of 1.5 meter. So this is what 1.5 meter is vertical drop plus 8 meter horizontal distance from your main board to the switchboard starter board of lathe machine, that is 8 meter plus 2 meter for extra, that is, it becomes 13 meter. So then the number of saddles required is equal to 13 plus 7, 20 divided by 0.75. 0.75, you know why we are doing it 0.75, because at every 0.75 we are using 1 saddles. So that is 20 divided by 0.75, which is equal to 27 number of saddles required. So this is how we have calculated the length of the cable required from your main board to the starter board of lathe, and from your starter board of lathe to the lathe terminals, and the PVC flexible PVC conduit length required, and the rigid PVC conduit length required we have calculated. So next we calculate, so the ICTP rating, here we are using ICTP because it is a 3-phase machine, we are using ICTP. TP. So it is placed in the starter board of lathe. So you know the load current is equal to, load current of lathe machine is equal to 2 HP into 1.6, that is equal to 3.2 ampere. While taking the ICTP rating, so we have to multiply by it by a factor of safety as 3 we have taken, that is total current is equal to 3.2 into 3, it becomes 9.6 ampere. Therefore ICTP of 15 ampere rating is required of 500 volt grade. Okay, so ICTP means ironclad triple pole switch, because it is a 3-phase machine we are using 3-pole switch. Okay, so next we required capacitor bank. Since the given HP of the lathe machine is equal to 2 HP, therefore 2 divided by 2.5, which is equal to 1 RKVA rating of capacitor is required. Therefore 1 RKVA 3-phase capacitor of 500 volt grade is used. Here 500 volt grade we are using because the lathe is a 3-phase machine. Okay, so then starter, since HP rating of lathe machine is 2 HP, 2, hence below 3 HP we are using, up to 3 HP we are using device starter, hence device starters are used here. Okay, so this is how to these are the materials required for the lathe machine starter board. Okay, so next we'll go for calculation of specification of materials and specification for drilling machine. So you know, so we have taken the supply from your main board to the starter board of lathe machine. Next we have to tap the supply in the lathe machine starter board, and it has taken to the switchboard of starter board of drilling machine, right? Means for the drilling machine, from where we are taking the supply? From the starter board of lathe we are tapping the supply and we are taking it to the starter board of drilling machine. Okay, so then the total wire length required from starter board of lathe to the starter board of drilling machine is equal to, means we are taking the supply from your starter board of lathe to the starter board of drilling machine, which is equal to 3 into vertical distance plus horizontal distance plus extra. So that is, you know, this calculation. So the distance from your starter board of lathe to the starter board of drilling machine is 3 meter. So, and we are taking 1.5 meter vertical rise, 1.5 meter vertical drop plus 3, this 3 meter is the distance between these two machine plus 2 meter for extra. 3 we are using, since drilling machine is also 3-phase, we require 3 cables for the connection. So the total you are getting 3 plus 3 6 plus 2 8, 8 into 3 24 meter. Okay, we required 24 meter cable. So what is the approximate load current of drilling machine? So HP of the drilling machine is 1 HP into multiplication factor is 1.6. if you multiply it, then you will get 1.6 ampere approximate load current. Then by taking the factor of safety as 2, then the cable required to carry the load current of 1.6 into 2, that is 3.2 ampere. Hence by looking at the cable table, size table, so we know that, so to carry the current of 3.2 ampere we required only 1 square mm. Therefore 1 square mm PVC insulated copper cable of 24 meter length is used. Okay, so next, so that is, we have taken supply from your starter board of lathe to the starter board of drilling machine. Next we have to take the supply from your starter board of drilling machine to the drilling machine terminals. So that is total wire length required from starter board to of drilling machine to the drilling machine terminals is equal to, so here also 3 into vertical distance plus horizontal distance plus extra. So then the total wire length required from your starter board of drilling machine to the drilling machine terminals is equal to 3 into 1.5, so that is vertical drop plus 1 vertical rise plus 1.5 horizontal distance plus 2 meter for extra, which is approximately 18 meter. Okay, then 1 square mm PVC, same size of cable we are using, 1 square mm PVC insulated copper cable of 18 meter length is used. Okay, so then we have to calculate the flexible conduit length and rigid PVC conduit length. So then how to calculate it? Let's see this. So total length of flexible conduit 30 mm dia required from starter board of your drilling machine to the drilling machine is equal to vertical distance plus horizontal distance plus extra, so that is equal to 1.5 meter, so that is vertical drop plus 1.5 meter vertical rise plus 1.5 meter horizontal distance plus 2 meter. So then it becomes approximately 6.5, which we are taking it to the whole number, that is 7 meter. Okay, so then the total length of PVC conduit 30 mm dia, 3 mm thick, required from switch starter board of lathe to the starter board of drilling machine is equal to, so vertical distance plus horizontal distance plus extra, so that is 1.5 meter vertical rise plus 1.5 meter vertical drop plus 3 meter horizontal distance plus 2 meter for extra, so that is total we required 8 meter. Then the number of saddles required is equal to, so this plus this 8 plus 7 15 divided by 0.75, which is equal to 20 numbers of saddles required. Okay, so then this is how to calculate the length of PVC conduit and the size of the cable and the length of the cables. Next, what are the materials you required? You required ICTP. So in the starter board of drilling machine, we have to place the ICTP. So then the rating of that ICTP can be calculated. So we know that the load current of drilling machine is equal to HP of machine, that is 1 HP into 1.6, that is equal to 1.6 ampere. So then by taking the factor of safety as 3, then the total load current is equal to 1.6 into 3, so that is 4.8 ampere. Therefore ICTP of 6 ampere rating is required. 6 ampere is market availability. ICTP, since the drilling machine is 3-phase, we are using ICTP, ironclad triple pole switch. Okay, then the capacitor rating. So since the rating given rating of the motor is 1 HP, therefore 1 divided by 2.5, which is less than 1, but we are taking 1 RKVA capacitor bank. So therefore 1 RKVA 3-phase capacitor of 500 volt grade is used. Okay, then the starter requirement is, since the HP rating of drilling machine is 1, okay, here the HP rating of drilling machine is 1, hence the device starters are used. Okay, so next, what are the other common materials you required in the wiring of this workshop? So earthing materials, right? For every machine we have to make 2 earthing points, right? Every machine is connected to 2 earthing points. So as we have seen in the layout diagram, we have made 2 earthing points, right? Every machine has to be connected to it by using 8 SWG GI wire. So therefore 8 SWG GI wire is equal to, here we are taking, so 2 kg per machine we are taking. For one machine we require 2 kg of 8 SWG GI wire for 2 earthing connections. Okay, plus 1 kg for main board we are taking. Okay, so then what is the total GI wire of 8 SWG required? 2 into, there are how many machines? Per machine 2 kg, but there are how many machines in our workshop? There are 3 machines, that is 2 into 3 plus 1 kg for main board, so that it becomes 7 kg. So next we require GI pipe, right? GI pipe for earthing, to make the earth pit, right? So to connect it to the earth, so that is GI pipe of 40 mm dia, 3 mm thickness we are using. So here for one earthing point we are using 2.5 meter, but in our layout diagram we have seen that we have made 2 earthing points. Okay, so then, so 2.5 into 2 earthing points, that is equal to 5 meter, that is for 2 earthings. Okay, so next we require teakwood board, of well varnished teakwood board we are using for the placement of starter board and main board and everything. Okay, so there are how many machines are there? So there are 3 machines in our workshop plus 1 main board we have to place, so that is total 4 numbers of well varnished teakwood board we required. So what is the size of that board? 700 mm into 500 mm into 45 mm teakwood board we are using for the placement of main board and the starter board of every machines. There are 3 machines, so 3 starter boards we required. Totally there are 4 boards required. Okay, and next we are having a single phase machine, so that is the grinding machine is single phase. So to tap the neutral we required a neutral link. Okay, so the neutral link for single phase grinding machine is equal to, we required how many numbers? So that is 1 number. Okay, so next miscellaneous items we required like cement, charcoal, nuts, etc. So that is lump sum we required. Okay, so this is how to calculate the materials and their specifications for the above said problems. So next we have calculated all the materials with their specification. Next list out one by one. Okay, we are listing it. So that is like this. So the 32 ampere ICTP main switch 500 volt grid. So unit is number. So that is the unit we required is one number. And how many numbers that is quantity required? How many numbers of 32 ampere ICTP required? So that is one number which we have placed in the main board. Okay. Next 15 ampere ICTP of 500 volt grade. So how many number of 15 ampere ICTP we required? So then we have to see it where we required 15 ampere ICTP. So we will go back to the ICTP ratings. So here you can see in the lathe machine we are using 115 ampere ICTP. So that is how many numbers of 15 ampere ICTP required? Of 500 volt grade, one number. Next 6 ampere ICTP we are using in the drilling machine, right? See, sorry, not drilling machine, where we are using that is 6 ampere ICTP is required for it is required for drilling machine. See here, so this is required for drilling machine. Next 15 ampere ICDP. So this is required for grinding machine. So DP means single phase supply, we are using ICDP. And 15 ampere 3 phase MCB. So that is in the main panel board we are using one MCB. So that is 15 ampere. So that is one number required. Next 3 phase 30 ampere ELCB with tripping current of 10 milliampere. So that is required in the main board. So that is how many numbers? One numbers. Next neon pilot lamps as an indicator. We required how many numbers of lamp? 3 numbers for RYB. We have calculated it. Unit is numbers. So next 1.5 square mm PVC copper cable of 1.1 kV grade. Okay. So the unit is coil. In the coil you will get 90 meter. We call it as a coil. So then what is the total quantity we required? Where and all we required 1.5 square mm. So in the grinding machines we required, and in the from your main board to the lathe we required, as we have calculated it. So next add up those cable length. So then it becomes 85 meter. Next 1 square mm PVC copper cable of 1.1 kV voltage grade. So then you add you see the previous slides where we used 1 square mm copper cable. So here you can see here, so you add this 1 square mm cable where we have used this. So then it becomes 42 meter. Okay. So next flexible PVC conduit 30 mm dia. We have used flexible PVC conduit everywhere from your starter board to the each machine terminal. So you add for 3 machines how much you required. So that is unit is in meter. So you require 21 meter. Next rigid PVC conduit pipe 30 mm dia 3 mm thickness. Unit is meter. So same, you add up the rigid PVC what we have calculated from your main board to the starter board of grinding machine, from main board to the starter board of lathe machine, and from your lathe machine to the drilling machine. So what is the total length you required? So you add all the three calculations, then you require it becomes 29 meter. Next saddles for PVC, as same way we have calculated saddles for each machine. So then you add up those saddles, it becomes 67 numbers. So that is gross. So we will not ask for one saddle, 2 saddles, some gross amount of saddles we take. Next 1 RKVA single phase capacitor of 230 volt grade. So the 50 hertz. So that is 1 for our grinding machine. Okay. So next 1 RKVA 3 phase capacitor of 50 volt grade. So that is 2 numbers. That is in the unit is number, and we require 2 numbers. 1 number for grinding machine and 1 number for lathe machine. Next varnished T-coat board of size 700 into 500 into 45 mm. So that is unit is number. So that is total 4 numbers you required. 3 numbers for 3 switch starter board of machines and 1 for main board. And 15 ampere porcelain neutral link we required 1 number. And 3-way gang box you required 1 number. 3-way gang box we required. And next 8 SWG GI wire. So you required 7 kg where we have calculated it. GI pipe 40 mm dia 3 mm thickness. So that is 5 meter you required. And miscellaneous items like cement, charcoal, nuts, bolts for making our earth pit and all. So unit is lump sum, some lump sum we have taken. So this is the quantity or materials required for the power installation of above said problem with their specifications. This is how you have to calculate the materials and their specification, and finally you have to list the materials like this: serial number, particulars, unit and quantity. So then for the above said problem, how to do the cost estimation, we will see it. So for the above problem, so if the cost estimation is asked, if they ask you to do the cost estimation required for the above problem or above power workshop wiring, so then how to do it? First, you know, you have calculated all the material in the same manner, and we have listed the materials required, right? Same in the previous table I have taken here. See this table, what is the serial number, particulars, unit, quantity. Same table I have taken, serial numbers, particulars, unit, quantity, and extra you have to do what? Cost calculation. You have to know the actual rates of each machine and while doing the cost calculation. Okay, here 32 ampere ICTP main switch 500 volt grade, you required one number, and what is the rate of it? 1250. So the total cost is 1250. Rate means the cost of each a unit. Okay, cost is total cost of that material. Okay, so here, so we have one quantity, so 1 into 1250, it becomes 1250. Next 15 ampere ICTP, so you required one number, so each cost 550 rupees, so the 1 into 550, it becomes 550. So next 6 ampere ICTP, we required one number, each cost 450 rupees, so 1 into 450, 450 rupees. Next 15 ampere ICDP, we required one number, each cost 430 rupees, 1 into 430, 430 rupees. Next 15 ampere 3 phase MCB, we required one number, each cost 550 rupees, so 1 into 550, 550 rupees. So next we have ELCB, we required one number, each cost 2500 rupees, so the total cost is 2500. So next neon lamp, each cost 30 rupees, we required 3 neon lamps, 3 into 30, it becomes 90 rupees. Okay, so next cable 1.5 square mm cable, we required 85 meter and it is 14 rupees per meter, so that is 14 into 85, it becomes 1190 rupees. So next 1 square mm cable, we required 42 meter cable, so for 1 meter it is 11 rupees, so 42 into 11, so it becomes 462 rupees. Okay, so next we required flexible PVC conduit, so that is 21 meter we required, so here it is 15 rupees per meter, so that is 21 into 15, 315 rupees. Okay, so next rigid PVC pipe conduit, so we required 29 meter, so 20 rupees per meter we have taken, 29 into 20, so that is 580 rupees. So next saddles, we required 67 numbers, so we have taken 1 rupees per saddle, so then 67 into 1, 67 rupees. So next capacitor bank single phase, we required one number, so that is 150 rupees we have taken, 1 into 150, 150 rupees. So next 3 phase 1 kVAr capacitor, we have taken 250 rupees for one number, so then 2 into 250, that is 500 rupees. Next varnished teak wood board, we have taken 400 rupees per board, so we required 4 numbers, so that is 4 into 400, so 1600 rupees. So next porcelain fuse link, neutral link, so that is 20 rupees for one, we required quantity of 1, so 1 into 20, 20 rupees. Next 3-way gam box, we required 1, so next 20 into 1, 20 rupees. Next 8 SW GI wire, so you required 7 kg, 150 rupees per kg, so that is 7 into 150, so that is 1050 rupees. Okay, so next GI pipe of 40 mm dia, you required 5 meter, for 1 meter it is 350 rupees, 5 into 350, 1750. Next lump sum materials like cement, charcoal, nuts, bolts, we have taken lump sum, so that is we have taken as 600 rupees as a lump sum, right? So next we have to calculate the labor charges. The labor charges, so you can see here labor charges. So for erection of panel board, one main panel board we are having we have considered for 200 rupees, that is 200 rupees. Wiring of machine power points, so that is 3 machines is there, for one each machine wiring we have taken 300 rupees, so that is 300 into 300, 900 rupees. Earthing works, there are 2 earthing works are there, 2 earthing points are there, So for each earthing points we have taken 300 rupees. So that is 2 into 300, that is 600. So then total labor charges is, so 900 plus 600, 1500 plus 200, so that is 1700. You can see here 1700. Okay. So next, what is the total? So that is total, it becomes 15,824. So next, contingency and unforeseen charges at 5%. So that is for the 15,824, you have to calculate 5% charges. So that is contingency and unforeseen charges we are providing as a 5%. So that becomes 791. So you add up this 15,824 plus 791, it becomes 16,611. Okay. So this is how to calculate the cost if for the above problem. Okay. So if any problem is given, in the same way you have to do the calculations. Okay, in the same flow or in the same manner we have to do. First we have, what we have done, we have made the assumption. Next we have written the layout diagram. Next we have calculated the materials required for main board, and next we have calculated materials required for each starter boards. Okay, and we have calculated, lastly we have calculated total lump sum materials required, that is teak wood boards and neutral links and earthing materials, everything we have calculated. Next we have made a table of the material with their specification and quantity, and next finally we have calculated the cost estimation. Okay, so that is the flow of calculation of given problem. So next, let's take up some multiple choice questions on this session. So that is, first question: how many kgs 8 SWG GI wire is required to connect the 3 motors to earth point? So here, so we have 3 motors. How many kgs of 8 SWG we required? You know, for each motor you required 2 kgs. For 3 motors, 3 into 2, 6 kg. The answer is 6 kgs. Okay. So then the length of PVC conduit is 60 meter. Then the number of saddles required are, option is 80, 40, 20, 50. So then, so you know, at every 0.75 so meter we are placing one saddles. Then the length of PVC is 60 meter. Then what is the total length of PVC saddles required? That is 60 divided by 0.75 you required. Answer is A, 80. So that is 60 divided by 0.75, you will get 80. Okay. Then next question: for 20 HP induction motor, the capacitor bank rating required is, so A options are A 1 kVR, B 2 kVR, C 3 kVR, D 4 kVR. Okay. So then, so you know what is the answer for this question? So you know, for every 2.5 HP we required 1 kVR. So 20 for 20 HP motor, how much you required? That is 20 divided by 2.5. You required 8 kVR capacitor bank. That is answer is C, 8 kVR. Okay. So next we'll go to the next question. So a 3-phase 5 HP lathe is to be installed 7 meter from the main board. Then calculate the length of PVC conduit required. Assume the height of horizontal run is 3 meter and height of main board and switchboards are 1.5 meter from ground, and consider 2 meter for extra. So here you have to install 5 HP lathe. So that is 7 meter from the main board. Then you have to calculate length of PVC conduit, right? So you know the length of PVC conduit is equal to vertical distance plus vertical run plus horizontal run plus extra, right? So here what is the vertical distance? So 1.5 meter from your main board to the horizontal run, plus that is vertical rise, plus 1.5 meter from your vertical drop from your horizontal run to the starter board of your lathe, and what is the horizontal run? That is 7 meter plus extra 2 meter. You have to calculate it. Okay. So then what are the options given? 22 meter, B 32 meter, C 42 meters, D 12 meter. Then what is the answer? So 1.5 plus 1.5, so that is 3 plus 7, that is 10 plus 2. Okay. So that is 12 meter. The answer is D, 12 meter. So next we'll go to the next question. A three-phase 5 HP lathe is to be installed 7 meter from main board. Then calculate the length of cable required from main board to starter board of lathe. Assume the height of horizontal run is 3 meter and height of main board and starter board are 1.5 meter from the ground level. Okay, so here you can see, so you have to calculate the length of the cable. Okay, what are the options given? A 24 meter, B 36 meter, C 44 meter, D 12 meter. So then what is the answer you will get? So here you have to the length of the cable is equal to, you know the formula, which is equal to, since the machine is three phase, so that is 3 into vertical distance plus horizontal distance plus extra, right? So that is 3 into, what is the vertical rise? 1.5 plus 1.5 plus horizontal run is 7, so plus extra 2 we are assuming, so that is 12 meter into 3, so 12 into 3, so that becomes 36 meter. The answer is B, 36 meter. Next we'll see the next problem. A three-phase 2 HP grinding machine is to be installed 3 meter from main board. Then calculate the length of cable required from starter board of grinding machine to the grinding machine terminals. Assume the height of horizontal run is 3 meter and height of main board and starter board are 1.5 meter from ground, and distance from starter board to the grinding machine is 1.5 meter. Then so options are 20 meter, B 30 meter, C 40 meter, D 10 meter. Then you have to calculate the length of cable required from your starter board of grinding machine to the starter board. So then the length of the cable is equal to, here it is a three-phase machine, so the formula can be written as, so which is equal to, the length of the cable is equal to 3 into vertical distance plus horizontal distance plus extra, right? So that is 3 into, what is the vertical distance? Vertical drop you have to take 1.5 plus vertical rise you have to take 1.5 plus horizontal distance you have to take 1.5 plus extra 2, right? How much you will get? You will get 6.5 meter, right? So that is 6.5 meter into 3 you have to do, because we required 3 cables, so that it becomes 19.5, that is approximately 20 meter. The answer is A, 20 meter. Okay, so next question, the copper cable size required for load of 415 volt 10 HP AC motor at 80% efficiency and 0.8 power factor is. See here, the given load is 415 volt 10 HP AC motor. It is a three-phase motor, right? So then the copper cable required to calculate that, you have to calculate the load current. So what are the options he has given? Option A 10 square mm, B 25 square mm, C 16 square mm, D 6 square mm. So then what is the cable size required? So first you have to calculate what? To calculate the cable size you have to calculate the load current. The approximate load current can be given by, so HP into 1.6, that is 10 into 1.6, it becomes 16, right? So then 10 into 1.6, it becomes 16. You have to multiply by the factor of safety as 2, right? So then it becomes 32 ampere. Then you have to look for the cable chart, cable size chart, right? Then to carry the 32 ampere current, what is the size of the cable you required? You required this cable size is 6 square mm. So that is answer is D, 6 square mm. Okay, we'll see the next problem. The copper cable size required for load of 240 volt 5 HP single phase AC motor at 80% efficiency and 0.8 power factor is. Option A 10 square mm, B 25 square mm, C 16 square mm, D 4 square mm. So then, so here also same. What is the answer for this? So to calculate the size of the cable, first you have to calculate the load current, right? The load current can be written as HP into 735.5 divided by voltage into efficiency into power factor. You do that, you will get a load current value of 23.94 ampere. By taking the factor of safety as 2, then you will get a value. So 23.94 into 2, so that is 47.88 ampere. So to carry the current of 47.88 ampere, looking from the cable size chart, we required 16 square mm copper cable. Okay, this is how to calculate the size of the cable. Okay, so this is about how to calculate the materials required for a given workshop, and how to calculate the size of the cable, length of the conduit, and all the things, and how to do the cost estimation for the given problem. So, and these are the some reference books which we are referring for this subject. Hope you understood this problem. So any problem is given, you have to do the problem in the same manner. Thank you everyone.